All right, I'm going to call it close enough to get started. Welcome, everybody. My name is Steve Smith. I'm letting go by Ardalis because there are far too many Steve Smiths. I work for Nimble Pros. We're a small consulting and training company helping teams write better software faster. And this morning I want to share with you some tips, advice, things to do, things to avoid with regard to primitive obsession and value objects, which you probably got from the title. So let's go ahead and get started. The first thing that I figured we should start with is just a quick definition of what is primitive obsession. And as any good starting definition slide goes, I'll make sure to use the dictionary definition. But for our purposes, a primitive is something that's built into the language. So if you're mostly .NET developers or C# developers, usually things like strings and ints. But whatever language you're in, if it has certain primitives like that, that ship with the language, and are not something that you're using to model your specific problem, then that's what we're talking about when we're talking about primitives. And then what's an obsession? Well, it's a fragrance, I guess, but it's also a persistent, disturbing preoccupation with an often unreasonable idea or feeling, according to Merriam-Webster. So, some examples might be an obsession with profits or an obsession with gambling. So, with primitive obsession, the question with this particular definition becomes, well, is it unreasonable to use primitives for everything? And many of us probably do or have, because it's easy, right? Like you don't have to write any extra code. You say everything's a string or an int or whatever, and things mostly work. So you'll spend a lot less time in a strongly typed language having to fix things and refactor things and to change method signatures if all of your methods just look like this. You have some string, return type, and you have some method that does whatever you need it to do, and it takes in a string. And you can literally write every method known to man using this signature. Maybe you also want an async task version of it too. But this will let you pass in anything you want and get back anything you want. And it's kind of the epitome of primitive obsession taken to an extreme. You can also do it with objects, but string is a little bit easier with if you're taking in JSON or something, you can easily parse it around. And you don't have to cast anything necessarily, right? Who needs types? How many of you are C# devs, by the way? Probably most of you. Okay, good. I'm talking to my people. So yeah, we'll talk a little bit about types in this talk. Okay, so what about this, right? If you have a customer class and it's got a bunch of properties that relate to the customer, like their name and their address. How many of you raise your hand if your code at work looks something like this? Fairly close, right? Yeah, this is what I see in almost every client I go to. This is what the model looks like. And part of the reason for that is that that looks a lot like a database table, right? There's usually a very thin line between what the persistence layer looks like and what our objects look like that we want to persist. And so the easiest, shortest path to getting stuff out of the database and then syncing it back in the database is to just do this. And you can almost have every one of those string types just be like varchar and varchar instead of string. Because that's all we're really doing here is putting a thin layer over the database. But we're in C#. We have types. It's a strongly typed language for a reason, and the compiler is there to help us and save us from ourselves when we try and do things that we shouldn't. Right? So let's talk about what the problem is with primitive obsession and why it is a problem, why it's something you might want to think about. One of the issues is you have an increased chance for errors. Right? And again, that's because the compiler is not going to save you. So if we take this exact same customer and we have some code that looks like this, at a glance, it probably looks fine. But if you look at it more closely, you might notice that somebody copy-pasted a line and then they changed one side but not the other, and now you're saving phone numbers in the email address field. And probably that all works, and your database will happily accept phone numbers in the email address column. And no one will notice until someone notices, right? Because everything compiles, everything runs, and it's great. But cleaning that up will be a challenge. And now you don't have anybody's email address, and you have to explain that to your boss. And so things like this are pretty common with the type of primitive obsession coding style that we see pretty ubiquitously. And so there's ways to address that, right? And that's what I want to talk about today. One of the ways that we address that, if we want to be careful and we want to make sure that doesn't happen, is by validating and making sure things are what we think they are, and they have certain characteristics. Right? And often that leads to duplication because of the nature of primitives. So one example of this is, let's say you want to validate a particular thing, in this case we say it's an email address, and I'm going to do the lightest possible validation of an email address. I'm going to say it's not null or empty. In fact, I even typed with this, I noticed it's like, if it is null or empty, But yeah, pretend that says if not string and null or empty. The other ones are okay. Yeah, we're going to do this check and in the API and the endpoint, and then we'll return a bad request if it doesn't pass, right? Now, the next thing we're going to do is call some service that's going to actually do the work of adding a customer, because we don't want to put too much into our endpoint and have it be super bloated and not follow single responsibility and all that good stuff, right? So as good, diligent, N-tier, whatever developers, we're going to extrapolate things into custom business services in another layer, and they're going to look something like this. Now, that service could be called from anywhere, right? Because we imagine to ourselves that we're writing reusable services that could be used from a console app or CLI or some other web forms, whatever, right? Most of the time, they only end up getting called by the one thing in that solution, but sometimes they do get called by others. And it's good defensive coding not to assume that someone else has done the job of checking that input. And so we're going to put in some type of validation or guard clause. And it's up to you when and where you choose to do one or the other. The difference between validation and guard clauses is that when you validate, it's usually user input, and it's not exceptional if it's bad. It's fine if it's bad. I'll just tell the user, hey, you need to give me this field that you didn't give me. That's not exceptional. That's expected. Users are going to leave things out. However, once you get past that, then you probably want to guard against invalid inputs. Now, a guard clause will throw an exception if the thing is not what you expect. And that is exceptional because it should have already been caught by the validation, right? And so if you're still hitting those guard clauses, that means you have a bug. That means you didn't validate properly, generally, right? So that's my really brief strategy for how and when I use validation versus guard clauses. But as long as you have a strategy for how you do it, and it works for your team, then that should work fine. But probably, if you're following defensive coding practices, you're going to want to check this at each level that it passes through. So in the service, it would not necessarily be prudent to do no validation and just expect that it was done somewhere else. Okay, so then we have a customer type, and it's an entity, and this is the thing we're going to store in the database, and it has all those properties I showed you before, but I'm omitting some of them. And it needs to have an email address. So in the constructor, it expects an email address, and of course it needs to make sure that that email address isn't null or empty, so it's going to do that check there as well. Now, at some point, the customer is allowed to actually change their email address. And so there might be a method for updating the email address. And naturally, in that update method, you'll want to follow the same rules and validate that it is, in fact, a valid email address. And for a real validation, you probably have a regular expression or whatever, right? Ignore that for now. And so you can see that just by trying to be diligent and write good code, you end up duplicating these checks in many places. And the big problem that we're addressing or seeing here is that the primitive type that you pass from one method into the next does not carry along any information. So you have a few issues here with that duplication. If the logic for how to validate the value changes, let's say we do decide that we're going to use a regular expression for our email address checks and not just check if they're null or empty, now we have 4 different places to go and change things. Have any of you heard of Shalloway's law? Shalloway's law says that when n things need to change, and n is greater than 1, Shalloway will find at most n minus 1 of these things. And so no matter how many things there are, this rule kind of holds. So you might end up missing one of those guard clauses or validation checks when you decide that you want to make things more restrictive and things actually have to have an @ symbol to be a valid email address. All right, so that's why the duplication is a challenge, among other reasons. Also just clutters up your code. All right, so you could just say that our strategy on our team is going to be, I'll just check everything in the entity. And to avoid duplication, I'll just extract a common method. Right? I've done this, right? So this can work. So here's an example of some code from another codebase where there's a required name, and inside of the constructor, we got that right there. We're going to say set the name property, and it's going to validate. And here it's going to set the name also when you go to update it, right? So now we don't have any duplication. That same guard clause is in that set name method. Now, does anyone see a problem with this, specifically if you're using an entity framework? Right? As it stands right now, it's probably mostly okay. The only problem you might run into is it might blow up if they don't have a valid name in the database, right? Because when Entity Framework goes to pull this out of the database, it's going to call a constructor. And so if you have guard clauses that trigger off of that, that could be a problem. But the bigger problem is when you add behavior, right? Let's say that now every time somebody updates their name or whatever property on the entity, you want to register a domain event, right? So that's what this is doing down here at the bottom. To say, hey, this was updated. And maybe that triggers something, maybe that pops a little alert up to the user, maybe it sends an email to an account manager to update their file, whatever. If you're using microservices, events are a way for you to keep them in sync. There's all kinds of reasons why you might want to have events occur when your model changes. And putting it in this set name place makes all kinds of sense. That's the place you probably want to do that. But now you've got this issue where every time EF calls the constructor, right, it's going to throw that event, right? And so even if you're just looking at these types, you're going to be sending off these updated events, even if nothing was updated except that this thing was hydrated from persistence. So that's not really great either. I do have a talk tomorrow on cross-cutting concerns like validation and things like that, so see me, I think it's in this room, like 2:45, if you want to learn more about that. All right. I've mentioned types a couple of times, because C#, strong types. When you're using primitives, you have much reduced type safety, right? So in strongly typed languages, you want to lean on the compiler. The compiler sometimes is referred to as your first unit test, right? And so if you can make it so that things that you don't want to happen get caught by the compiler, that's always much better than getting caught by a runtime exception or unit test or the CI/CD pipeline checks it or something like that. Right? The closer to when the developer made the mistake that you can tell the developer they made the mistake, the less costly it is for them to fix it. Right? They're still in the zone, they still know exactly what they did. Okay, so common pitfalls are things like this, where you're using too many primitives. Right? We've got some method that just wants to add an order to a customer. It takes in their IDs. That's all it needs. It's going to add a record to a many-to-many table with both IDs. And then somewhere else, somebody calls that, and they transpose the two values. They're both integers, so it compiles and runs just fine. And if you're using identity columns, it's likely that whatever customer IDs and order IDs you have, they exist in both tables. Right? If you tell customer 1 to add order 1, well, there probably was an order 1, there probably is a customer 1, but they may not be the ones you wanted to match up. In that case, I suppose if you transpose them, it won't hurt. But if you have customer 100 and order 200, let's say, you can probably transpose those, and they'll both still exist, but they won't be the ones you meant to do. So that's another problem. So the big issue that we run into overall with primitive possession is this difficulty in maintenance. And you see it because of the code duplication. You see it because of the lack of type safety. There's a more cluttered code base because there's checks everywhere for these things to make sure that they're valid. And I'm showing you things that have literally one field that you're trying to check. When you have methods with half a dozen or a dozen inputs, and you need to check all of them, right, you have many lines of code of just checking things in every single method along the way. And it really obscures the actual intent of those methods. You also have a lack of encapsulation because you can't trust primitives. That's the big problem. Primitives don't allow for any encapsulation of behavior with the value. The whole premise of object-oriented programming. All you have is the value, right? And the only way you can have behavior is through like extension methods or just writing your own if statements around it. And having to code around primitives is the big problem that you run into with primitive obsession. So another principle that I'm fond of that you may not have heard of before is the single point of enforcement principle. And it's this idea that if you have some business rule or some policy that you need to apply consistently in your code base, there should be a single point of enforcement for that rule. And so in the case of the email address that I was showing you, right, we had to check that in many different places because of the fact that we're just using a string for it, instead of just having one place where we could do it. So with primitives, you have no single point of enforcement, and in essence, anywhere that you accept in a string or int or whatever, you're responsible for making sure that it's the proper thing that you want to work with. The other problem with primitives, which I've kind of mentioned, you kind of get here, is that they don't carry any history or context. So if you do the checks in the first method, and then you create another class or service and call it, and pass that primitive into it, it has no idea what has already passed. Right? All of the knowledge that you know about its validity is lost as soon as it gets passed on to another method. And so you're having to relearn over and over again, which is very inefficient. And if you look at code and you're stepping through it, and you're seeing the validation checks in every single method, or guard clauses in every single method, right? You may even ask, like, is this efficient? Is this having a runtime cost? And probably it's not. Probably it's trivial. But it is having a maintenance cost more than anything. All right. How many of you have heard of this principle? Parse don't validate? Not very many. All right, good. Then you'll benefit from this. I didn't come up with this. There's a link here that someone wrote it in 2019. But I really like this concept. And the basic idea is, instead of validating things in many different places, whether it's a DTO or your entity or that integer, right, parse it into a better type. right? So when you validate something, it gives you this transient knowledge. It gives you this Boolean of yes, no, it's valid or it's not. And you only know that within that one local context. And it doesn't pass along with the type. When you parse, we get additional knowledge. So imagine you took in a string and you did, try parse or parse into an integer or into a DateTime, right? And then you call something else now with that integer, with that DateTime, right? You've just increased knowledge and used a more specific, more constrained type than what you started with, right? And that's the whole idea, is we want to take an unconstrained type, like an int that can be anywhere from minus 5 billion to positive 5 billion or whatever the range is, and say, no, we're using this for the quantity in the shopping carts. We think it should probably only be from like 0 to 100, right? And that's it, right? You can constrain things, and then once you pass that on, no one else has to check, right? They don't have to worry, is this thing in that range? So when you pass on primitives, you have two choices. You either have to duplicate those checks, or you have to accept the risk of using the values as is and just kind of hoping that someone before you did those checks, and that they did them well, right? When you do the parsing to the restrictive thing, you ensure that it can only be in representable states, right? And that's another important principle that I really like, which is that you should not have a model that can show I'll just show it. You want to make invalid states unrepresentable in your model. Okay, this is another principle that I'm a big fan of. So the best way that I know of to ensure that you don't have bugs in your system of things like, this was invalid, and we got dirty data in the database, or they bypassed this rule because we had duplication, we didn't do the check here. Right? You get rid of all those bugs when you make it so that your model simply cannot reflect those invalid states. Right? And there's all kinds of examples of ways that we do this, and most of them have to do with primitives. Things that you'll see are like, you've got some collection type, and it needs to have, let's say it's a photo album, and it needs to have a photo album cover image, right? And so every single photo in the album has a bit field that says, is cover image. Well, it would be possible for all of them to have that set to true, right? That's a state that your model could represent. But you can't have more than one cover image, so then what happens, right? The system has to just pick one or grab the first one, whatever, right? It's not really a known state that should happen. And so you have to code around it. Whereas if you just had the album had a cover image ID property, let's say, or even just a type that was in that collection, it's still possible that could be null or something like that, but it will not be more than one, right? And there will be at least only one in that collection that is that coverage. And you might still have other edge cases you have to account for, like, well, we put an ID in there, but it's not in our collection, it's from some other collection, right? So you have to cover those things too. But you get the idea, like, the closer you can come to having a model that does not make it possible to represent invalid states, the better you'll be able to reason about your system. And this becomes more and more important the more complex your model becomes. So, value objects are a really big thing in domain-driven design, where it's all about taking complex models and mapping them in some more or less correct way that represents how the system should work. If you're just building a CRUD system and you just need to get stuff in and out of a database, all of these things are going to be much less important, right? And you can just do probably model validation API and call it a day. But when you have that complexity, this is when you want to be able to apply these types of patterns. All right, so let's take a trip for a moment and imagine that in the .NET world of the last 24 whatever years since they shipped it, nobody ever thought that they should add system.datetime to the system. All right, so we'll come into Visual Studio and we'll see what that would look like if we were all coding that way. And so I have a really simple web app down here. It's got a controller, it's got an appointment. Let's start with the appointment. Okay, so you can make an appointment, and an appointment will have a start time and an end time. And we'll represent the start with the year, the month, the day, the hour, and the minute when your appointment starts, and we'll represent the end with the same things, but for the end. And so when you take in the appointment, when you have a constructor, right, we have to pass in all these 10 or so different fields or variables so we can assign them. And then I've been kind and pulled these out into a helper method, but you could imagine a whole lot of if statements here to check all this. But we'll look at the method, and it's, check the year and the month and the this and the that, and to make sure they're at this time. And I cheated a little bit and used this DateTime helper to get the days in the month. But otherwise, there'd be a whole switch statement about which month is it, how many days are there, and yada yada, is it a leap year? And all that complexity would be in every single method or class that had to deal with a whole bunch of ints for date times, right? And then I've got this appointment service that's responsible for creating and updating these things. Now, it takes in a DTO, and of course, it wants to make sure it has valid data, so it has its own valid date time check that it does, which looks a lot like the other one, but it could vary and be different. And then it, sets all the properties and passes them in the constructor, and then, saves them and all that. And an update, of course, has to do the same thing. So when you update it, it's doing all that validation as well. This is all called from a controller, and all this code works, right? And the controller has API controller on it, which means it automatically does model validation. But when I asked ChatGPT to generate this for me, it was still putting these in because it's stupid and doesn't know that that's already done. If you didn't know that, by the way, if you have all these if model state is valid things in your code, and you're still using controllers, just go put API controller on them, assuming they're for APIs, and it will do that for you, and you don't need any of that code. So that's your quick public service announcement. So anyway, in here we just call the service and have it do its thing, and in return, we're doing a try catch here because if we get an argument exception, it's going to be that argument exception that we threw saying, hey, it wasn't a good date. Right? But normally I don't recommend doing try catches in your controllers for bad requests. So then this DTO that it's using, we also want to make sure that it's being validated. And so we're using a bunch of validation here. Now this is not perfect. Right? I can validate that the start date is between 1 and 31 using a range, but I can't validate that if it's February, it shouldn't be 31. That's not as easy. But I'm checking for that further in, right, with increased logic. And so if you've done all this, you can go and use an HTTP file in Visual Studio, and you can choose some dates like, whatever, 2025, 1, and it says 16, 1, and look, the end here is before the start here, but we're not actually validating that. And we can say that we get a 200 okay. If you're not using HTTP files, and you're still using Swagger or Postman or other things, like these are really convenient for Visual Studio, and they get checked in with source, so everybody on your team can use the same HTTP file. It's really nice. All right, and then if you do something that violates the rules, like I said in the rules that my range could be 1999 and you send a request, you'll get a nice error here that says one or more validation errors occurred, 400, start year must be between 2000 and 2100. So you get what you would expect. But you have to check all those things yourself, right? And so if you think about it, DateTime is a value object, right? It's an excellent value object. It's an awesome value object. So we should just take that example and do things like DateTime does in all of our code for things where you've got a couple of related things. You've got a first name and a last name. We'll make that a name value object, right? And then you can render it in a consistent way and not have every place anybody renders it have them two-string it in their own custom way. There's not lots of reasons why the DateTime is so convenient, and hopefully by kind of considering for a moment what would my life be like without it, right? You can see like, wow, it's so nice that we have DateTime, right? I'm a big fan. I like DateTime. And they've added some new things recently to make it easier to mock it and test it too. Okay, so why aren't we just doing that? Why don't we just do what they do with DateTime everywhere? Anyone? Does what?
It doesn't reflect that in the database.
It doesn't reflect that in the database? Well, yeah, it's true. If we want to persist that thing with all those integers, I'd have to do some kind of database trickery or just have a bunch of int columns in the database. So yeah, the database does get in our way a lot. But the other reason, well, let me just cut through here. So because we have DateTime, we don't have to do all these checks everywhere, which is nice and makes our lives easier, obviously. So the question I already asked, why don't we do that with our types? It's probably because DateTime is 1,700 lines long and does all kinds of great stuff for us, but Microsoft is responsible for maintaining that, and we don't have to write that code. And if you're trying to do something comparable or similar in your business application with a deadline looming, it maybe isn't your biggest priority, right? I think is more often the reason. And if you look at the top line here, line 57, on this screenshot, you can see all the interfaces that DateTime implements, right? It's comparable, it's formatable, convertible, serializable, comparable of T, equatable of T, right? Every one of those interfaces, you have to kind of know how to implement and write some code to actually implement. And that's why this thing is so long. In addition to, there's a lot of tricky logic with dates and Gregorian calendars and leap years and things like that in this particular case. All right. But what if I told you that you can do this in just a few lines of code, right? If it was only a few lines of code, or like an attribute, right? Maybe that would make it worthwhile to start using value objects, a little bit more often than you do now. Also, what if I told you But Morpheus never actually said, what if I told you? You didn't know that? All right, so that's the problem space that I want to talk to you about. Right? That's the primitives, that's the issues that they bring with them, and probably you've experienced most or all of those. And so let's talk about different ways that we can solve this problem. And so the solutions are generally going to be types, types like DateTime, types that have more constraints and restrict the types or the kinds of values and ranges of values that are allowed to be within those types. And these are often referred to as value objects. So what is a value object? Well, it's a custom type. And it is composed of primitives or value objects. So what that means is it will not have a property that is a list of entities off of it, right? Or something that has pointer references to other things. Generally, it's just going to have a few primitives, and that's it. But it can also be composed of other value objects. They should be immutable, and there's good reasons for this, right? You want to be able to trust that when you get a value object as an input into your method, that it is valid, right? That's the whole idea. That's the whole value proposition for a value object. And the only way you can know for certain that it's valid is if it wasn't changed since it was created. Because when it was created, that's when all the checks are run, right? This is how DateTime works. Again, if you think about it, right? When's the last time you had to check on a DateTime type that the month was less than 13? We don't do that because we know. Well, why do we know? Because you can't change a DateTime. If you want to modify a DateTime because you would need to add a month to it or whatever, you have to call DateTime.addMonth1 and you get back a new DateTime. You didn't mutate the one that was there, you got a new one. And that's what you do with your value objects as well. If you need to be able to change their values, you write methods on them that return new value objects with the new values. And you don't allow for mutation of the value object itself. That way, you can have a single point of enforcement, which is the constructor of that value object, to ensure that it is always valid. You can't create one in an invalid state. Value objects have no identity, so they're not entities. They're not going to have a key in your database. They're never going to have an ID. The value object is just represents something, right? Just like the number 123 does not have an identity. If you have 1, 2, 3 in two different places in your code base, you can say they're equal, right? Because they're just the number 1, 2, 3. And so that leads into another feature of these I'll get to in a second, which is how they're compared. They're typically attached to entities, right? So they get persisted to the database as part of an entity. And in your domain model or in your business model, right, they don't really have any meaning unless they're attached to an entity. So if I give you a date of 2025, January 15th, what is that? Well, it's just a date, right? But if I tell you that, hey, that's, my session is on January 15th, 2025 or whatever, right now you know, like, oh, I'm attaching that to an entity that has some ID that I can reason about. And so these value objects generally have to be a part of an entity in your business logic for them to be meaningful, for them to have any real impact on your design. Now they won't be attached at first, like when they come in from the user input, they're going to always come in as a primitive, right? So when you get them, they'll be an int, they'll be a string, maybe they're DateTime. And then you will parse, validate them into your value object to then turn them into the type that you're going to use as part of your model. They should typically represent a business concept, a domain concept, so something in your model. And it doesn't have to be something that you use all over the place, right? Reuse is not necessarily the goal. Even if this thing only exists in one place on one entity, you still get the benefit of not having all that duplication running through your whole stack of trying to check it everywhere, right? So it's not a matter of, well, it's not really worth doing a value object because I only use it in this one place. Right? There certainly is more return on investment if it is used in many places, but I don't think that's necessary for it to be valid. And then the way that you compare them is strictly by their state, by their properties. So if they have the same values for the properties, then they're equal. If they don't, then they're not. But again, there's no identity factor in comparison with them. All right, so that's a quick overview of value objects. Now, many people get confused because, especially in .NET, we have this notion of value types, which is not at all the same as value objects. So in .NET and CLR, we have value types like ints, and we have reference types like string. And it's important to know the difference between these as a .NET developer because of things like how they involve pointers under the covers, and how they're passed, and whether or not you get a copy of the thing, or you get a reference to the thing. And none of that has anything to do with value objects. So just understand that when we talk about value objects, they're different from value types, and they're not really related concepts in any way. It is possible that you can make a value object be a reference type or be a value type. It just depends, and usually it depends on what the underlying thing is. So if you're making a value object out of a string, it'll probably be a reference type. If you're making a value object out of an int, it'll probably be a struct or a value type. Right. I should stop for just 1 second and say, are there any questions so far? Yes, sir.
When you were talking about like a value type or value objects, as opposed to primitives or other value objects, what if like arrays? I don't know, like how like arrays or like lists or vectors aren't really primitive, but like say like in your example from before, like a person might have multiple appointments, and how would you like represent that?
Usually, it's a good question. Usually collection types are not good candidates for value types because they're usually reference types that refer to collections of entities. So when you go to persist that, whatever's in that array or that vector or that collection, they're probably going to get persisted in a separate table as a bunch of individual rows. Those individual rows are probably going to have IDs, right? And so having that entire vector or array or collection be a value object usually isn't the design that you'll choose. Because it's very difficult to make that immutable, it's difficult to reason about it the way we would a value object. Instead, you would make it so the things that are in that array, right, there are appointments in the array, or there are references to something else in the array, right? You could make those value objects, and then it's not at all unusual to have simple entities that have a single ID property and then a value object property. Right? And so you put all of the logic of, is it in the right range, is it valid, yada, yada, yada. You put that into the value object property, and then you just slap an ID on it so that you can persist it. And then if you need a collection of them, then you just put all those entities now into that collection, and that's what you pass through. Does that make sense? Other questions? All right. So there's a couple of options for when you're building these value objects. And so these are from open source NuGet packages that I'm showing you here. Neither one of them is mine, and I don't get anything for talking about. One of them is from C# functional extensions. It's a really popular NuGet package, and they have some abstract base classes for value object as well as comparable value object. And they basically do the work of handling the operator overloading, the equals, the get hash code, all that stuff that most of us don't want to have to deal with and probably don't know how to deal with correctly because there's certain rules for those things. And you'd have to look it up and figure it out. It's a whole thing. They just do it for you, and you just import this package, say your value object inherits from it, and then go about your day. Now this is for composite value objects. Right? So if you have an appointment and it has a start and an end, and you would like to make that whole appointment a value object, this is a good candidate for that. Because things that have multiple different primitives as part of them, as a composite, it makes sense to put them into a class that wraps them, and then use something like this base type to give you the equality and the other features of it. It's up to you when you implement your class that inherits from this to make sure that it has certain characteristics like being immutable. So when you want to be able to change that thing, instead of having settable properties, or instead of giving it a way to just update a property through a method, you'll give it methods that are going to give you a new instance of it in that new state. Okay? So an example of one of these would be, here's an address value object. It has, in this case, still a bunch of primitive types for street, and city, and state, etc. But the only thing that you have to implement to make it work with the value object base type is this IEnumerable of get equality components. And so this is the pattern that they've chosen to use. It works pretty well, it's pretty flexible, where they just need to know all the things they need to compare when they check equals, right? And so they're going to enumerate through this list and check each one in turn and say, are they the same, are they the same, are they the same? And if they all are, then we'll say they're equal, and if they're not, then we won't. Now, in many cases, you may have some properties that are there for other reasons, for some business reason, for auditing or something else, that you don't want to be involved in the equals check. And so if you want, you have the flexibility, you can leave those out. All right? And now, even if those are different, right, they'll still say, yes, they're the same. Like, this address is still the same, even though the name is different, let's say, or whatever the person that we're shipping the thing to is different. We'll leave that off and say, well, the addresses are still equal regardless of who the name is, whatever your business rule might be. All right, so we'll see this in code in just a second. The other option is to use a source generator And there's a few of these out there, but one that's my favorite right now is called Vogen. And when I first saw this, I was in my head, I'm thinking it's Vogen, like Vogen's, like, you know, Hitchhiker's Guide. But no, it's Vogen. And I would never remember that, except that I now know where the name comes from, which is value object generator. Right? And once you know that, then it's like, oh, gen, yes, it's generating. And maybe they needed to make it capital V or capital N. But Vogen, right? And it's Steve Dunn's project. It's actually gotten pretty popular on NuGet. It's got 1.5 million downloads at this point, which is pretty good because it's not that old. And it's using source generators. And it's really nice because you don't have to write all that code. You don't even have to have that code somewhere in a base class or somewhere you have to muck around with or put in source control. All you have to do is attribute the thing that you want to turn into a value object and say what its underlying type representation should be. Right? And so this is actually really useful for IDs, which I haven't covered yet with some of the pitfalls of primitive obsession. But you can take your IDs and turn those into value objects and make it so that you're not going to have those. I did show the example with the customer in the order ID. That type of thing is impossible when you use strongly typed IDs because it would give you a compile error if you try and pass in order ID for a customer ID, even if they're both ints under the covers. So when you do this, it's important that you mark it as partial, and then when you compile your code, the source generator is going to generate code like this. Right? And so all of this code you kind of just get for free at compile time, and it's very fast, and it generates it all so it's there. And the nice thing about this is at runtime, all that code is there. There's no reflection. There's no overhead of it trying to do reflection, scan properties, figure out if things are equal. A lot of earlier value object implementations use that type of approach, which, as we all know, reflection is not the fastest way to write your code for runtime. And so this is more code, but it's all generated code that you never have to look at, and it's super fast at runtime. In fact, he's got some benchmarks on his GitHub repo that show that it's like within a couple percentage points of just using the primitives everywhere. So with no extra memory overhead. So it's a really nice implementation that we're using. Okay, so why not both? Why don't we take our composites and use this value object base type, but make the things that those are compositing be Vogen value objects instead of primitives? And so here's another example of a name value object, which would have whatever your rules are for legal name for the first name and legal name for the last name instead of strings, right? And now this can still be a value object that can have the equality components and everything else, but the legal name is now its own value object, and it's got that attribute. But in addition to that attribute, some other things that Vogen lets you do are add validation. Right? And this is a key point because that validation runs automatically when you try to create one of these, and it will fail if it's not following rules. Right? So if we want to say that legal names can't be empty, then we can do this check in the validation on the name when it's created, and if it fails, it won't create it. Right? It'll get an exception. Also, you can do other things. I haven't used this one as much, but it's pretty nice for like this type of scenario. The second thing, where you can normalize the input somehow. So if you always want to make sure that passwords or usernames or names in general are trimmed and you don't have white space on the beginning or end of them, you can do something like this, and it will ensure that every time you get this value object, it's trimmed. Right? There's no extra leading, trailing, whatever white space. And again, single point of enforcement. This is the only place you have to do that. If that's the rule, this is where you implement it, and now you're done. You don't have to check it anywhere else. All right, so what about persistence? Right, that's been the thing that's really made this a challenge for the last few years. Like I've really wanted to use value objects in this way and work with EF core and work with a persistence ignorant domain model for a number of years. And Vogen is the first thing that's come along that kind of makes that possible, and it's always possible, I guess, but makes it easy, relatively speaking. And so you can easily now take, with Vogen, these strongly typed value object-based properties on your entities and round trip them to the database using Entity Framework, as well as the other thing that's often a challenge is serialize them to and from JSON with just a couple lines of code as well. And so that's been really nice. So what's time at? 20 minutes? That's probably more than enough. Let's look at EF Core and Vogen and how this works in Visual Studio. All right, so we're going to stop this web app and switch over to this other demo. And all this stuff is on my GitHub. Ardalis, and then there's one called value objects demo. There'll be a link in the slides. Okay, so in here we're going to look at laborer, I think. Right? And so laborer is just an entity, and instead of having an integer ID and a string name, I've given it these strongly typed value objects for its properties. So all of its properties for this entity are things that you can reason about, and I don't have to do any checks for them. And so when you look at the constructor, one of the things you might notice is like there's no guard clauses or anything here to make sure these are in the right range or any of that, because I know they are, because they are the types that I'm looking for. And if I'm using the C# nullable reference type support, I can also be pretty confident that they're not null because I didn't allow them to be null here. It's not quite as strong of a check because someone can still just pass in a null with an exclamation point, but I've chosen in this case not to check that they're not null. All right, so this laborer ID, let's look at that first. Right, it's really simple. It's exactly what I showed you in the slide. We just mark it up with value object of int, and now it's essentially an integer. And so when I want to work with that, I can get the ID from an integer by writing some code and saying dot from int, and it will give me back the type that I want. So I want to show you how that works. It's in the demo, maybe. Yeah, let's show it with the name. All right, so here's an example of how to build the name. And so to get a legal name, which is wrapping a string, from a raw string, you just say legal name.from, and that's kind of the convention that Vogen uses as sort of its factory method. And so any generated value object that Vogen gives you will have a .from on it where you can pass in the underlying type, and then it will run its validation, run its normalization, and give you the wrapped value object version of that. And so the legal name, I already showed you the code for it. It looks like this, and you just saw how you can get one of these from a string. You pass it into the name, which is here, which I also showed you on the slide. And then this is a value object using the base type from C# functional extensions. Okay, so there's not a ton of code here. We're just using strings. And then where it really matters is the fact that you can store it in the database. So if we look at the demo, we're going to use the DB context. We'll add a worker, we'll save the changes, and make sure all that works. So let me just verify that's still working. I didn't break it recently. There's a few examples in here. There's model 1, which doesn't have any value objects, and then a basic one, and we're just looking at model 3. And so here you can see model 3, saved it right there. So it works, right? So we were able to save it to any framework. Now, why was that a challenge until recently? Until recently, you had to do a lot of work to write conversions inside of your on-model creating or inside of your configuration class to make it so that when any framework looks at a legal name, it has no idea what that is. What do I? There's no legal name column type in SQL Server. What do I do with this? And so you'd have to say how to convert that. And so one of the nice things that Vogen does, if we look at the configuration for laborer, is that we can say, let's look at the ID first. The ID is of type laborer ID, right? It wraps an int, but it isn't an int. And so the one line of code that we need is this has Vogen conversion. Actually, there's 2 lines for this one. But the has Vogen conversion is what tells it that we're going to map it to and from an integer. And so you don't have to write that code yourself. It's pretty simple to write if you need to for yourself, to just turn something into an int and back. But Vogen generates that for you if you ask it to. And I'll show you where you ask it to in just a moment. And so this is pretty easy. The other thing you need is the value generator. And the reason for that is that by default, Vogen is not going to want to let you create these in invalid states that are empty. And so if I have an ID type and I have a constraint on it and I say I only want these to be 1 or higher, because database identity IDs aren't supposed to be zeros or negatives, it could be. It's going to blow up when I try to pass in or create a new laborer and I don't pass in an ID or I pass in an empty ID. It's going to blow up and say that's not valid. That's not a good typed ID. And so what you might have noticed inside the editing that we do to make this work is even though this is not a laborer ID question mark, a null laborer ID, because you wouldn't really want that. You want your entities to have an ID. right? We're still going to kind of cheat a little bit and say, well, no, we're going to make sure it starts out as null and trust us compiler, we know what we're doing. Because that's how the entity framework knows that it needs to be a new record. And so when we pass it in with an empty ID, it's going to generate the new key for us. And so the code for that is fairly straightforward, and it's this value generator. And so this is all code that you can just steal off the Vogen website. You don't have to write it yourself. But you do need it for each one of your IDs. And so I don't have it in this example, but in my other sample, I'll show in a second. You can create a generic one of these that works for every ID in your solution, so you don't have to write it over and over again. But the basic idea is just to allow it to be 0 for that moment when you're creating the entity. And that's just a special case for IDs that you don't have to worry about for most other things. Okay, so then in AppDB context, the other thing is, I mentioned, where do you tell it that you need converters? There's a couple ways you can do that. You can say it well, you can say it anywhere with a partial class where you give it these attributes and say EF4 converter of whatever value object, right? So it will generate those converters so that when you then say in your configuration that this thing has Vogen conversion, it does, right? Because you told it to, right over there. It's now those two things connect. Similarly for the legal name, right? The first name and the last name on the name, they also need to say has Vogen conversion. And the place where that happens is again generated from right here where I said for legal name, generated converter. The other place that you can do that if you wish, if you prefer, is right on this attribute. You can pass in here and say, here's my conversions, and my conversions include, JSON serialization and entity framework core and whatever else you want. There's a whole bunch of them that are already in there by default that you can use. So probably whatever way you need to pass these things around, it probably exists. Now, the only reason I don't really like that is because usually I build systems that try and keep the infrastructure concerns at arm's length from the domain model. And if I put this in my domain model, and then I say, hey, this value object has a conversion of EF core, that only works if I take a reference to EF core, which I don't like to do in my core domain model class, or project rather. And so that's why I prefer to do it using this type here, because this type can live with your DB context. It can live in that other project and not make it so your domain model has to know anything about EF core or JSON serialization or what have you. All right. So I think that is closing in on most of the things with Vogen. I do have another quick demo to show, but I'll make sure I don't miss anything here. Does anybody have any questions or anything we're not seeing here? Oh, the other one I should mention. This is old, it's been around for a while. So since like EF Core 2.1 or something, there's been support for something called owns1, and this is how you do the value objects that are composites. And what owns1 does is it will put it in the same row in the database, but prefix it with your column name, right? So if we were to do a migration, do I have migrations here? I don't know if they're up to date. If we did a migration on this labeler and they have a name and that name has a first and a last name, right? What you would see in the database columns is name underscore first name, comma, name underscore last name is two separate columns. And so that's how owns1 maps to and from the database. And that's been, like I said, that's been around for a while, and that's what works with the base value object type for composites. All right, how many of you are using entity framework core? Everybody on like 6 or later? Most, a few of you? Who's like stuck on earlier than EF Core 6? Anyone? All right, good. Who's stuck in .NET 4.8? Yeah, that's terrible. I have clients. We're trying to move to .NET 8 now. It's so much better. We're down to 9 now. All right, how many of you are already doing stuff like this? Any of you? How many of you are going to be doing stuff like this now? Oh, a lot of you. Yeah. All right. Let me show you this other demo. Here. All right, so this is from my clean architecture template that I have on GitHub. And so there's a sample folder in there that has a more complete sample than just the template. And so this is where I pulled that example that I showed you in the slide with the contributor, where you can just do this set name to try to avoid duplication in your entities. And I told you why that's not great. What you can do instead, though, if you use Vogen, is you can take in, something like this, where I've got this project, and one of the other things that I like to do is have a base type for my entities, right? Because I know they're all going to have an ID. I probably have a common type that I use for all those IDs. So instead of having to remember to put an ID property on every single entity, I'd rather inherit from a base entity type that has an ID on it. And so I have this entity base of, in this case, it takes a project and a project ID. But by doing this, I'm able to create a single value generator that Vogen can use for all of my entities. That just checks and says, hey, is it one of these types? Is it an entity base of something, something? Then, okay, I know how to generate values for that. And so by just doing that, you only have to have one of those, which is what I was showing earlier. Again, when you use a name that is not just a string, it makes it much easier for you to pass around. You don't have to do as many guard clauses or checks. You can just trust that it is in a valid state. And all of that is again, just simple Vogen. Here's some other things you can do with Vogen. There's a whole lot of capability to it. The docs are pretty good. Other things you can add into this. These are assembly level directives where you can tell it how it's going to do the generation and some of the different things it's going to generate. And then here's an example of if you want to do system text JSON, you just say conversions include system text JSON. And now we can pass this around even through the API if you want. Now, I don't necessarily recommend that. So one thing we haven't quite talked about yet is where do you start and where do you end when you're using these in a more complex system, right? Where you have endpoints and you have services and you have a domain model. So let's wrap up by touching on that. So in an endpoint for, this is the thing I want to change, right? I want to change or create a project. And a project has a value object for its name and has a value object for its ID. And down here in the web, I have an endpoint for project that does create, and it takes in a create project request that just takes in this string type. And of course it takes in just a string type, because all I'm getting is a string over HTTP, right? HTTP isn't going to automatically give me a value object. And so inside of the actual endpoint, I'm going to take in the request. I'm going to map it to a command in this case. You could just take the request and pass it along. But I'm just going to take in that string and pass it to my command. And then I have a handler for that command that's right here. And it does the actual work of creating the project. And so it's in here that will say, here's the project name coming from request.name. So it does that translation at the use case level, or if you have services at the service level. I'm a big fan of using individual use cases with handlers these days, and I'll talk a lot more about that in tomorrow's talk as to why. But it makes for a really clean way to structure your system. And it's in that next layer down. Stop that. It's in that next layer down that I like to do the translation from the primitives that you're getting in. After you've done model validation and model binding and all of that, and you've got the request, then at the service layer, at the use case handler, translate that into your domain model, which means using those value objects and things from there. Other people have different opinions on that. Some people will just use them as their model, right, on their DTOs, and they will make it so using JSON serialization, they can map directly, and even though somebody posts a string, they get in a strongly typed name type, whatever it might be, right? You can do it either way. It's up to you which one you think works best for you. Yeah, all right, so let's go back to slides. Almost done. All right, so things to remember, takeaways. Avoid primitive obsession where you can, obviously. They don't have a single point of enforcement, so you're going to end up with duplicate code that can be difficult to maintain and kind of clutter up your code base. Remember, parse don't validate. If you remember one thing from today, even though this isn't even like part of what I was talking about so much, like keep this one in mind because it makes a lot of sense. Right? Like as you're getting input in from the user, it's generally unstructured string input coming in over the wire or from a text box or whatever. And you need to be able to turn that into something that makes sense to your domain. So instead of passing around that primitive over and over again and continually rechecking it to see if it's good, parse it into a real type that you know is good, just like you saw with DateTime. Also remember, don't allow your model to represent invalid states if you can. It'll make it much easier for you to reason about it, and much less likely that you'll have bugs. Think about date times. Every time you're thinking about a value object, that's like the Uber value object. It's like the best example out there. So if you like DateTime and you like what it gives you, remember that you're going to get that for you and the rest of your team if you start using value objects yourselves. Create composite values with value objects with base type, create single value objects with Vogen, and then combine the two together like chocolate and peanut butter, and you get the best of both worlds. Here's a bunch of links that you can take a picture of if you want that has more stuff about me and more resources from this talk, including the demo, repo, URL, and then the sample I showed from Clean Architecture, that's the Clean Architecture repo. And I've got about 5 minutes for any last questions. Yeah?
I was thinking about the collection question from before.
Right.
Is there an opportunity for a valuable object if you have validation rules like for the collection, like?
I typically do that in aggregate. So that's another DDD pattern called aggregate, and you basically have something contains that collection, or something could or should contain that collection. And so the thing that owns that collection is called the aggregate root, and its job is to enforce any rules on that collection. Like they have to be unique, right, relative to one another, or there can only be 10 of them, or whatever those rules might be. Right? Individual items in a collection can't enforce rules that are collection-wide like that because they don't know about their neighbors. And so you need a parent object that owns those sub-entities, and that's usually called an aggregate. And its responsibility is to ensure that that's always in a consistent state. Another question, yeah?
How do you feel about implicit conversions from value objects?
Good question. I meant to include this. All right. So the question is, how do we do implicit conversion from value objects? So I've got an int value already, and I want to get an age, let's say, or a quantity. Usually, it's fine to go in one direction but not the other. So it's kind of the same rule as if you have a short and you want to cast that into an int. Like you can put a short into an int, you don't lose any information, so it's totally fine. But you can't just take an int and make it short because it might not fit, right? And so you can take an age and turn that into an int if that's what it is under the covers, and just do that implicitly. But if you want to take an int and turn it into an age, well, you don't know if it'll fit your rules, so you've got to do a dot from and run all the checks that Vogen has. So you can always go from more constrained to less, but you shouldn't go implicitly from less constrained to more constrained. Does that make sense? Okay, good question. I do have some stickers and some decks of cards that say Nimble Pros on them up here for anyone who wants them. So feel free afterward to come up and grab some if that's your thing. And otherwise, thank you very much. Don't forget to fill out your emails. I'll be around for a couple minutes.